Hello again. So, to continue this video series, now we're going to add a finishing toolpath. This is a little bit more involved than the previous ones. So what we're going to do is we're going to go to 3D 5D Advanced, and we are going to choose 5D by meshes. So this gives us a full 5-axis toolpath based on the surface given by the mesh of the object. Okay. We are going to set that to avoid collisions. Sorry, that was part of the link and lead editing we did in the previous video. It was saving that because it tends to default to using the previously given links and leads for the start of the previous toolpath. Obviously, that's generally fine, but in this instance, very much not so. So we always have to check the approach and return details in links and leads, just in case there's something that trips us up a bit further down the line. So, other settings that we need to account for with this, the first thing we need to do is we want to set the tool orientation again. And in this case, we want to set the tool orientation to 1 in Z, which means that the tool automatically looks down. Okay. The next thing we want to do is we want to set the rotary table vector to positive X again. Okay. And we want it to be able to rotate E2. So after that, we're going to go to strategy, and you see we've got different options here now than we did have before. What I'm going to do for the moment, just to make life simpler for ourselves, is I am going to set the rotary axis so that's in Z, because you can see at the moment it's off axis for Z because it's based on the robot's tool position. So we're going to set that to Z so it's perfectly perpendicular to the base of our model. And I'm going to set the bottom level to about halfway down his face maybe, just so we can work out all of the kinks of getting the toolpath correct without having to do a huge amount of computing each time we want to rerun the toolpath. Because as we saw with the previous toolpaths, the more complicated it gets, the longer it takes to calculate. So we are going to want to sort out. That looks good so far. So we're going to press generate toolpath and see what it comes up with to start with. Right, okay, so we've got a few interesting links and leads coming in there where it's not quite sure what's going on, and it appears to have developed a couple of gouges. Obviously this isn't ideal. So I'm going to turn on singularity avoidance angle. We also want to make sure that it's happy doing side tilting. One thing I'm going to do as well is I'm going to tell it to check the spindle. So what we can do here is we can define tool clearance and tool angular clearance. Now if you okay, so I've just put that up to 50 because it's wildly exaggerated, but you can now see where there's that big angle there. Again, that doesn't hurt us too much in terms of actual functionality, but what it does do is it means things like the tool collet nut and everything won't interact with the final piece. This is vitally important because there's nothing worse than trying to clear up a gouge in a hard material where you can't naturally put some of it back. Obviously, if you're machining lighter things like foam, it's still not ideal, but it's less of a concern. If, however, you're machining wood, stone, metal, this is not something that can be fixed afterwards. Okay, so that otherwise all looks okay. We're going to set the safe surface to a cylinder which wraps around the model as well. Sorry, that's under links and leads. 10 millimeters from the part, that's calculated based on the original workpiece surrounding it, I believe. No, it's not. That's actually calculated from the part itself. My apologies. Right, so we try simulating that and we'll see what it does. There we go. That's already looking a bit cleaner. Now, if we go to one of the one of the really powerful tools that ENCY has at its disposal is the axis mapping tool, which allows us to deal with any kind of redundant axial movement that would otherwise be very fiddly to control in other systems. Specifically, it allows us to chart a map which gives a clear indication as to where there are collisions or singularities come into play. Sorry, for some reason. Singularities are typically left on by default for calculation purposes. They're kind of irrelevant to this particular toolpath because we've already accounted for it by setting the orientation of the tool and the approach, so the robot doesn't have any decision making involved in that. So if we now click on build map, we can see that there are some small out of limit sections there, but nothing drastic. So if we click on build graph at this point, it tells us it's impossible to find the way. I'm not convinced. So what I've gone and done there is I've double clicked in the chart itself, and that means that we've now defined the path it's going to take. So we can update the toolpath, and automatically you can see everything's a bit cleaner and happier there. What we can also do is we can click and drag along here, and that will actually indicate where in the toolpath process the robot actually is along here. So it's worth noting that the bottom axis here is the distance along the overall toolpath, and the top axis from the center goes to -180 to +180, which is the range of the sixth axis of the robot, which is what we're controlling here. We also have similar controls for axis E1, E3 and E2. E2 and E1 are turntable axes, and E3 is the linear axis on this robot, which we've been ignoring thus far. Anyway, so we've got an updated toolpath. That generally looks good. We can try simulating it now. So we've still got all the simulation work that's been done on the two roughing water lines. I'm going to slow this down and bring it in and start with this. And we can see at the moment that although it's making the turntable do quite a lot of the work involved, it's generally looking pretty good so far. I did, however, spot something on the way here that might make it look a little bit worse. One of the things that I forgot to do earlier on is to set the radial and axial stock offsets on the roughing toolpaths, so they by default go all the way down to the 0 point on the final model. However, due to the way that ENCY is constructed and the way that it calculates toolpaths, this is not a huge issue. We can go back and resolve that momentarily without a major loss in time. Okay, so I'm going to speed this up so we can see what kind of a state it's in for the moment. Generally, it's looking very good though. And once it's reached the end of this toolpath, as I say, just for the sake of being able to verify for our own sanity's sake, there you go, that looks quite decent. We can go back to machining, and we can go back to roughing waterline 1, and under strategy, is it strategy? No, sorry, under parameters, we can go to radial stock, set that to 5mm, and axial stock, and set that to 5mm as well. And we can do the same for roughing waterline 2. So now we're going to have to recalculate everything, which is fine. You know, it's worst thing it's going to do is make some computer fan noises for now. So it's not like other CAM programs where sometimes this can cause problems with the entire workflow up to now. In ENCY, this is not a big deal. There we go. Seems to have happily calculated everything now. So we can go back to our 5D by meshes path now. And as I say, generally what we've seen so far has been good. So what we can do is we can set the bottom level now down to the very bottom. And based on the calculations that we've made so far, and based on all of the settings that we've given so far, we should be able to get a fairly coherent path from it at this point. There you go, so that's calculated quite happily. I don't see any horrible lead-in or links or anything there. That looks good. So if we simulate now, we reset the simulation and we click on simulate up to current operation, and then we press play, and it's looking good so far. And as we can see, when I was talking earlier about this being a full 5-axis operation, you've got the head tilting out of the way to avoid any kind of interactions between the tool head and the actual workpiece itself. So I'm going to speed this up a bit for the sake of expedience. And if we start to see any alerts or crashes, I'll slow it right down again so we can take a look at them. But so far, this is looking good. Perfect. So there we go. In not very long at all, we have managed to generate a fully sorted out Batman statue. Thank you for your time and thank you for watching. I hope this has been informative. Obviously, all of the original files can be found in the ENCY library folder as well, so feel free to download and deconstruct any of those as you see fit.